Today we're going to take the mystery out of quadratic equations. So the lecture today says understanding quadratic equations. So what are quadratic equations? Well, what they are is a relationship between two variables, typically y and x, and it typically will look something like this. Y equals ax squared plus bx plus c. Now that's the standard form as we call it. A, b, and c are simple constants, any sort of numbers. X is the independent variable, and then y is a dependent variable. So, as an example, let's write an equation such as y equals, let's say, x squared minus 6x plus 5. Okay, in this case, a would equal 1. That's the coefficient from the x squared term. B is equal to minus 6, and C is equal to 5. All right. Now, one of the things we want to be able to do with one of these quadratic equations is learn how to graph it. Another one is learn how to find the roots. But before we get into all that, let's kind of get a general feeling of what a quadratic equation is. It's, again, a relationship between x and y, so we should be able to graph it on an xy plane. So there's our y-axis, there's our x-axis. And typically a quadratic equation will be graphed, either it will look like this or it will look like that. And the way you can tell if it's going to open upward or open downward, as we call it, is if the number in front of the x squared term is positive, it looks like this. So that's a plus a. And if the number in front of the x squared term is negative, then it'll look like this, so think of it as a minus a. All right, that helps us a little bit. Now also realize that if you graph these, that this parabola, as we call them, these graphs for quadratic equations called parabolas, and it could potentially, if we were to graph it, it could end up looking like this, or it can end up looking like this, or it can end up looking like that, or maybe it looks like this. And notice that in some cases, the parabola will cross the x-axis. Like this particular parabola will cross it in two places. This particular parabola will cross it in two places. And these two parabolas do not cross the x-axis at all. The places where one of these parabolas, which is a graphical representation of a quadratic equation like this, where the parabola crosses the x-axis, those are called the roots of the quadratic equation. So we call these roots. And here again, these would be considered the roots of the quadratic equation. Notice that these two do not have roots. So sometimes when they ask you to solve a quadratic equation, they're basically asking you find the roots of the parabola. And of course, if the parabola does not cross the x-axis, like again, this is here the x-axis, this here is the y-axis, like in this case or in this case, then there's no solution. There are no roots to the quadratic equation. All right, so to help us figure out what it actually is and how to graph these quadratic equations, let's go ahead and factor this. This happens to be a factorable equation, so we can write this as y is equal to the product of two binomials. We write the x and the x. Since there's a negative here and a positive there, that means one must be plus and one must be negative. Or no, in that case, I'm sorry, actually they both must be negative. Negative, because the only way you can get a positive number there is either that you have two positive numbers here or two negative numbers, and since this is negative, you have to have two negative numbers. So now we're looking for two numbers. When you multiply them, you get a 5. When you add them, you get a 6. So it looks like a 5 and a 1, because if I multiply x times a negative 1 and multiply negative 5 times an x and add them together, I get a negative 6x, my middle term. All right. Now, if we want to solve a quadratic equation or find the roots, realize that the roots are the points that lie on the x-axis. That means at that location, the y value is equal to 0. So any point on the x-axis, my y value is 0, which means if I'm going to find the roots, I'm going to set my y equal to 0. If I do that, this equation now becomes 0 is equal to x minus 5 times x minus 1. And if I solve this for x, then I will find the points where the equation crosses the x-axis. All right, now if I two quantities multiplied together and the solution is 0, that means either one or the other must be 0, because the only way you can multiply two things together and get 0 is if either x minus 5 equals 0 or the x minus 1 equals 0. And of course, if x minus 5 equals 0, then x must equal 5. Or if x minus 1 equals 0, then x must equal 1. And those are the locations in this particular example where the parabola will cross the x-axis. So if I'm going to graph what I have here, my example, if I'm going to graph this example on my xy axis here, I know that one of the roots, or one of the points where the graph will cross the x-axis, x equals 5. 1, 2, 3, 4, 5, so right there. And the other place where it crosses the x-axis will be at x equals 1, which is right here. And those are considered the two roots of my quadratic equation. All right, now there's another thing about a quadratic equation that's very important. It's called the axis of symmetry. If I find the midway point between those two numbers, so this is 1, 2, 3, 4, 5, and so the midway between 1 and 5 is the number 3. If I now draw a dashed line, vertical line, through the point x equals 3 on the x-axis, that is now called the axis of symmetry. And again, if you look at my examples over here, if you draw a line halfway between here and halfway between right there and right in the middle there, right in the middle there, right in the middle there, and right in the middle there, notice those lines, those dashed lines, are the exact line that divides a parabola in two equal parts. Therefore, that's called the axis of symmetry. Now, notice that the number in front of the x squared term is positive. It's a positive 1. That means the parabola opens upward. That means I'm going to have a parabola that looks kind of like this. To find a few more details, if I now plug in to my equation the value of x where the axis of symmetry goes right through, in this case, the number 3. So I'm going to solve for my equation when x equals 3. That's, again, the point where the axis of symmetry goes right through. Let's see what I get. So I'm taking my equation, and instead of x, I'm going to write a 3. So I get a 3 squared minus 6 times 3 plus 5. So notice I took my original example, and instead of an x, I write a 3. Instead of this x, I write a 3. And if I work that out, I get 9 minus 6 times 3 is 18 plus 5. And so that's plus 14 minus 18. That's equal to minus 4. So that means when x equals 3, my y will be negative 4. So 1, 2, 3, 4. That's negative 4 right here. So x equals 3, y equals negative 3. That is the bottom or top point of my parabola. So if my parabola opens upward, the lowest point of my parabola is this point right there. If my parabola opens downward, then my lowest, or in this case my highest point right there, will be that point right there. So in this case, since a is a positive number, my parabola opens upward, so this will be my lowest point on my parabola, also known as the vertex. So that's the vertex of my parabola. Now there's one more special point about the parabola. Sometimes the parabola will cross the y-axis, like over here. In this case, it doesn't look like it, but if it goes on, if you keep going long enough, again, eventually you will cross the y-axis. Right here, this parabola crosses the y-axis over here. And if this parabola goes on long enough, eventually you can see way down here somewhere, the parabola will also cross the y-axis. How do we find that point? Well, remember, anytime you cross the y-axis, that means that the x value must equal 0. So to find that particular point, we take our initial equation again and plug in 0 for x to see where the equation or where the parabola crosses the y-axis. So I'm going to solve for y when x is equal to 0. And again, I take my equation right there, plug in a 0 for every x that I find. So I get 0 squared minus 6 times 0 plus 5, or y when x equals 0 is equal to 5. So going to my example here, my graph, when x equals 0, my y value should be 5. So It's 1, 2, 3, 4, and 5. And so my parabola must cross that point as well. Now notice I have 4 points. I know my equation can be graphed like a parabola. Here's my lowest point, or the vertex. There's my 2 roots. There's the point where the parabola crosses the y-axis. If I now carefully connect all those dots with a free hand like that, I have now drawn a graphical representation of my example right here, my quadratic equation, and you can see how that looks like a nice parabola. So that's what a parabola is. That's what a quadratic equation represents. And if you want to look at the points very carefully again, notice you have the lowest point on your parabola called the vertex. You have the 2 points where the parabola will cross the x-axis. Those are also known as the roots. So that's a root, and that's a root right there. Also notice that most parabolas will cross the y-axis, and when they do, that's the point you can find. You can find that point by plugging in 0 for x in your equation. And then, of course, the axis of symmetry runs right midpoint between the 2 roots, or also goes right through the vertex. So there you get a pretty good feel for what a parabola is and for what a quadratic equation is. All right, now we're going to show you some examples of actually how to solve these quadratic equations and how to graph them in a little more systematic fashion.